Thanks to the organizers of the GTM conference for inviting me as a speaker to this event. My talk will be a cross-disciplinary one. I'll try to bring kind of two disciplines together, which are closely related, but so far we have seen limited interaction. So I see that there's a kind of a great potential to bring the efforts of text mining, big data with foresight, which is all about shaping and designing the future. So if I had the chance to ask the audience, of course, how many people heard about the term foresight? I guess maybe half, maybe less, would say they heard about the term. So there are certainly some newcomers to this domain. So I'll try to give some kind of a brief introduction to the field, and then we'll try to tell and discuss how we make use of big data and what are the future opportunities. I really wish to get engaged with this community. I see that there are really great potentials. So I will try to raise some areas and some gaps that we may want to address together. So foresight is the application of systematic, participatory, future intelligence gathering and medium to long-term vision building process to informing present-day decisions and mobilizing joint actions. So this definition tells us that the foresight is not about predicting the future. So we don't try to forecast necessarily. We try to design the future. And we try to do this in a systematic process with the use of a combination of quantitative and qualitative tools. And we bring different stakeholders together. And these stakeholders include the scientists, academic community, higher education institutions, as well as industry, policymakers, and broader society together to build some common visions for the future. And we'll look beyond the normal planning time horizons to cover some uncertainty so that this uncertainty will give us a chance to design the future. And then we don't only design the future and leave it there, we try to connect the future with the present by developing some long-term, medium-term, and short-term strategies. And then we want to make sure that our foresight informs our present-day decisions and actions, because we know that if we want to achieve change in the future, we need to act from the present. Foresight is important. It is a first step of innovation. As Einstein said, it's imagination is more than knowledge. So imagination, creativity, forward thinking, future thinking. So these are important steps for innovation. So foresight is actually placed at the very first stage of the innovation process. It helps us to build future visions and then to set priorities strategically, because we have limited resources, we have limited time, limited funding, limited skills. So we want to use this as strategically as possible by optimizing the use of our resources, limited resources. And then this is a great opportunity again to bring together stakeholders. Foresight creates a platform for mutual learning, for collective intelligence, for thinking out of the box. And in this way, we try to anticipate emerging and evolving trends, future wildcards, and again, weak signals of future trends. And then we try to prepare for all these developments in advance. And we also believe that there's not one possible or probable future. There are multiple futures. So we try to capture all this through our foresight exercises. So we want to see what, if we can develop some robust and resilient strategies to be prepared for unknown and complex future. So the activity has been there. So it is not new, actually. We all have foresight, our individual foresight. So the act of anticipation as a human characteristic, we always think about the future and we always take our steps according to that. So if we are here, for example, at this conference, right at this moment, so that means we prioritize this conference and this event. So we would like to be here because we believe that the knowledge we will gain from here, the experience and exchange we will get from this platform will help us to achieve our future expectations, career expectations, expectations in corporations, in the, again, in our academic life or research life. So each of us have different expectations. So, but what we saw later was that we started bringing all this individual futures thinking, individual foresight together to create collective foresight. So these were actually the foresight exercises, which we call this institutional foresight exercise. And what we mean by institutional is that we moved from individual foresight to collective foresight and institutionalize them and systematize them by bringing some new tools and techniques, some new processes, approaches, methodologies into the process. We started seeing a number of technological forecasting activities, for example, in the 1950s and 60s, during the Cold War processes. So all kind of defense-oriented technology forecasting activities to develop the best defense technologies. And then as we moved in time, decade by decade, we saw that actually the global context is changing. So as our foresight practice, so we started introducing some new concepts, new approaches, new methodologies. For example, during the oil shocks of the 70s, we started thinking that we cannot actually forecast the future precisely. So the future is uncertain. And this was the time when we brought multiple futures thinking into our understanding of foresight. And then in later times, we understood that innovation is a key driver for economic development. And innovation is only possible if we can bring together stakeholders to set up innovation systems. So that is when foresight activities became inclusive and participatory. And in later times, we started using foresight not only for economic purposes, but also for social development, to get some social benefits. And foresight has become an instrumental tool for science and technology policy making by government, industry, and others. So as we are coming closer to our present time, we started seeing that there are a number of grand challenges that we need to address and societal problems. So we started using foresight activities for global issues, water, energy, food, and other topics. So there are a lot of foresight exercises done not only at the national levels, not only at the corporate levels, but also at the global level by international organizations. So the evolution of the world is still going on, and the evolution of foresight is still going on. So foresight is changing the world, our foresight is changing the world, and our practice is also affected by those changes. So we continuously observe and adapt our foresight approaches according to this changing world. So what we see recently is development of technologies, big data technologies. For example, data is now created all over the place on a continuous basis. So we need to make use of this new evidence for our foresight activities. Previous foresight activities were relied mainly on expert opinions, but now we have very valuable tool, which is called data. And now we are trying to develop some ways of using this valuable data to get some intelligence and at the same time build some evidence for our decision making. And in the future, we see that there are some expectations in terms of human and technology convergence, co-evolution, And we know that all this kind of developments will also impact for foresight. So I'll come back to that point during my presentation. So we did recently a science mapping analysis to understand how the field of foresight is evolving. So this picture also clearly shows. So there are earlier foresight activities, technological forecasting, technology-oriented focused foresight, and then later broader foresight activities with technology and social focus. And in the past 20 years, we started seeing this evolution much clearly. And our science mapping exercise, based on data from 25 journals publishing on foresight, future studies, innovation, and policy, showed us this evolution. So we clearly see that we have started moving from innovation foresight, again, foresight activities for formulating innovation policies, and then move to industrial policies, systemic foresight exercises which bring together these different aspects at multiple levels of governance. And more recently, we started seeing applied foresight. So if you look at the clusters we identified through the science mapping exercise, we see that applied foresight represents business, organizations, industry, systems thinking, and also bringing a number of issues on the agenda like security, drug development, for example. And if we go into details, we will see, for example, other areas like the use of data coming also on our agenda. So I'll just focus on, for example, two of those clusters, which is a citation cluster, because this is a term which probably has been used a lot since the beginning of this conference. So you see that on the agenda of foresight, we are talking about emerging technologies, disruptive technologies, discontinuities, and the technology trends. And also we look at citations to understand what technologies are emerging, what technologies are disruptive, what kind of discontinuities we see in this data. And we do also bibliometric analysis. And we see that a number of studies have focused on, for example, the domain of nanotechnology. So this will probably not surprise you. If we go to another cluster, we see that this is about tools and methods. So we see that we started combining this data and big data with other tools that we have used traditionally in the foresight process, like Delphi method. The Delphi is an expert survey method, and we are integrating now use of data with integrated into different foresight processes and foresight methodology. So if we look into the other clusters too, we will see that foresight is becoming more data-based and more evidence-based, plus it is also making use of its existing tools and methods. And we also anticipate next stage of development in foresight following this trend. So we recently discussed the concept of foresight on site. And this actually represents an understanding of foresight being integrated into almost our daily activities. Because even with this pandemic, for example, we don't know what will happen tomorrow, next month, or next year. It is very uncertain. So even the next year became a long term, considering the amount of uncertainty and complexity we faced. So this was a great opportunity. At the same time, it is a disaster, but at the same time, it is a great opportunity to explain people why we live in a complex world and why many different issues are connected to each other in a systemic way, for example. So the pandemic is not only a health issue, it's a social issue, it's an economic issue, it's a technological issue. So there's so many different issues interacting in a systemic way, which actually force us to have futures thinking even in our daily activities. So this is why we are introducing the concept of foresight on site. we can also use this trend in the use of foresight methods. So here is an analysis we did a few years back. It clearly shows how the methodological toolbox of foresight is getting richer and richer. At the beginning, we relied on only a couple of methods, one or two scenarios, Delphi methods, and the others. As we come closer to the present time, we see that there are a number of methods, including quantitative, qualitative, or semi-quantitative or qualitative, some combinations of them. You can see that our methodological toolbox is expanding, and there's a great room for integrating big data and foresight together. In our recent exercise we did for South Africa for the formulation of South Africa's science and technology strategy for the year 2030, we used foresight in several ways. For example, we considered that big data in that process plays a critical role. And then we try to kind of integrate foresight and big data in a kind of fully fledged activity to design strategies and policies for a country. And during this time, we were able to use big data to create agenda and scope for foresight and select priority areas to focus and provide evidence for the areas under investigation. So we were able to identify trends, weak signals of future trends, wildcards, those surprises and shocks, technologies, products, and future markets. And this was also very helpful in terms of testing the feasibility of future visions and existing capacities. For example, in this foresight exercise, everybody was talking about information and communication technologies. These are platform technologies which are relevant to all sorts of priorities like education, health, water supply, employment, and so on. But what we saw is that we shouldn't take these technologies for granted, because when we analyze the capabilities, we saw that there is not sufficient ICT capability to support all these priorities. So it was a very interesting case in terms of seeing this gap between the future vision you have, but the existing capacity levels you have again at hand, and the big gap. So that actually gives a clear message that you need to develop this capacity in your country first if you want to make use of it in the future. In our institute at the Higher School of Economics, National Research University in Moscow, we are developing an intelligent foresight analytics system. And this is bringing a number of different data sources together, because we think that it is important to look at these data sources in a kind of a complementary way, because each of these data sources will tell us a different part of the story. So some of them are talking about the like blue sky technologies and developments, and the others are telling us what is actually on the way, what research projects, and which research is coming closer to technologies, which technologies are available, what kind of technologies again could be used for what sorts of products. So we look at, for example, patent data for that. And we also try to understand what is going on with policy, regulatory framework, for example. And sometimes we cannot find all the data we need in publications and patents. In those cases, we look at international conferences. A number of companies now developing international events and conferences to launch their new products and new technologies. So it's very important to keep an eye on these events too. And also, of course, media, social networks, professional blogs, and bringing them together with expert opinions. So we try to integrate all this using big data, machine learning, semantic analysis, and text mining tools. And then we still value our experts. Experts are still important because they can interpret all these outputs coming from data analysis. So we try to kind of combine these two processes together and to generate some outputs for technology foresight, and strategic planning in the form of some STI, science and technology priorities, technology roadmaps, and sometimes, for example, we'll look at job advertisements to understand what kind of skills are required by companies or governmental institutions. And so we try to make sure that we keep an eye on all sorts of different trends which form our life, our world in a kind of a complementary way. So I'll try to present a few examples on how we make this happen, how we make use of this big data. As I said, it is important for us to map science and technology development in a certain area, like in the area, in the domain of energy. When we do a foresight exercise, of course, we try to first identify what we are focusing on. What are those important and priority topics that we need to consider? When we do a mapping exercise like this, we see those areas which we need to cover under energy, fossil fuels, hydrogen production, solar cells, for example, energy density, fuel cells, consumption, and etc. So we go again with this kind of picture and representation, and we discuss it with our stakeholders and experts in panels, and then determine priorities and scope and main focus areas of a foresight activity. And again, this shows a Sankey diagram. It shows a structural changes analysis of science and technology trends. So you see how dynamic the fields are and how fast they are really changing. You see they are expanding. There are some new areas emerging, some areas are merging. So this sort of analysis helps us to understand the dynamic characteristics of science and how things are evolving in a particular scientific domain. Here also we understand what is on our agenda. So what are those mature areas? What are those key areas or drivers of developments at present? Weak signals, which may be like future trends and drivers. They are less significant right now, but at the same time, fast growing areas. So we keep an eye on them because they may become trends in the future sometime soon, or they may just disappear. But again, there are some potential areas which may emerge as the trends and drivers which will shape the future. And there are also some niche areas that we try to keep an eye. You may consider this probably as some of the kind of wildcard areas that may, again, unexpectedly become mainstream. We can match some technological areas with some application areas. I'm hoping that the text is not too small for you to read. If you look at full screen, it will be fully visible to you. So this is showing us which technologies are, for example, used to address which diseases. For example, for breast cancer, the preventive medicine, nuclear medicine, genetic engineering, DNA sequencing, and these are some of the technologies which can be applied for this purpose. And at the same time for obesity, for example, again, genetical engineering, preventive medicine could help us to address the disease of obesity. So it helps us to link between different areas. You may consider these technologies and markets, technologies and products, or any other 2 or 3 sometimes dimensional entities that you want to relate to. And this is an important picture for us. A life cycle analysis of science and technology development. So you can see we try to bring different kind of information sources together. So we look at grant data, we look at research articles, patents, and professional media, because we think that actually in some cases, or most maybe research areas begin with a grant, right? So you have resources, and these grants may come from different places, from National Science Foundation or from some companies or elsewhere, and then we begin the process. And this process actually triggers some kind of a research activity, and this research activity is represented in the forms of some scientific articles. Then this research is translated into some technologies and products, and we find them in patents. And then later we see that these are launched to the wider world. So we can see some areas, some new areas, for example, like perovskite solar cells. We didn't see this concept in earlier years, but when we came to 2013-15, we started seeing that this concept started emerging. And other areas which have some grants, but we don't see much capturing of them in professional media, or some areas like unmanned aerial vehicles, which we see a lot in professional media. That means actually there are already some products and some markets available in the world, but the area is still funded. So they are showing the stage of development in different technological areas. This is a kind of a visualization of hypes in science and technology. We'll look at those areas which are, for example, mentioned in media and in articles and patents in scientific and commercial maybe work. So what we want to see is the fit, if there's any fit. So there are some areas in media, so which are not supported by scientific work. So that means there might be some hypes around these areas. And there are some areas under articles in scientific work, and they are not covered by media yet, so they haven't emerged yet. And there are some areas which are well researched and society is aware of this development. And it helps us actually to see what is real, what is on the agenda of science, and what is not on the agenda of science yet, but covered by media. So we need to actually see the fit between them to understand whether an area is a hype or not. We can also extract information through some semantic analysis from a wide variety of sources. We try to kind of understand, because there are so many documents talking about the same topic, for example, future ICT markets. So we try to bring all these forecasts together to build some sort of a collective intelligence, again, coming from different sources. And sometimes we use this collective intelligence to build some forecasts. And we try to find some kind of range between future forecasts coming from different sources. And when we put them together, we see that there's a certain kind of range. And some of them are out of this range, but there's a consensus. For example, on ethanol production in Brazil and how this is estimated in different sources. So we can see in what range the production would be. So this is what we have so far. And this is what we are going to. So the world is evolving and things are changing, and we are moving into some sort of digital futures. And as part of this conference, I listened to some of your presentations and then looked at the agenda of the conference carefully, and saw that we are talking about a number of different technologies, a number of different scientific areas, application areas, and so on. The reason I'm showing such a crowded picture is actually to explain that all these scientific areas and technological developments will exist together. So they'll not happen one by one. We will have new ways of information gathering and analysis. We will have new ways of innovating, new ways of developing infrastructure, new ways for production, for example, new ways of social interaction. So we need to look at the world again as a big system of interacting technologies. So extrapolating one technological or one scientific development is not enough for us to foresee the future. We need to see the holistic picture and see how these systems of technologies actually work.
Ozcan,
Yes.
can you bring to a conclusion? This time is up for talking.
I'm coming there in 2 minutes, if it's okay. For the future of Foresight, we know that we are going into artificial intelligence. So when we try to kind of map the developments in the artificial intelligence, we saw that there are a lot of messages for Foresight, for future decision making, like human-machine collaboration, artificial creativity, unsupervised machine learning, automated decision making, human-like decision, robotic policy, for example, technological prediction. So we see that there are some new developments coming on our way, and we need to understand how we can make use of this artificial intelligence for our future foresight. If we look at the steps of foresight, I can show that actually we have some steps. So I'll just go through this very quickly. A foresight process starts with scoping and renewal, and then we try to understand emerging trends. We explore alternative futures, build some visions and priorities, and then strategies and roadmaps for those priorities. We plan actions, and then we make evaluation of our activities. And of course, all these activities happen in a participative and inclusive manner. So there are a number of potentials for using big data. I try to kind of look at the conference agenda, and I started seeing that there are some studies already from this group of people, which can be fit with our foresight activities, but there are still a lot of gaps. So if anybody is interested to, for example, discuss how we can use big data, text mining, technology mining for scoping foresight, to build alternative scenarios, to prioritize areas or build strategies, I'm very happy to discuss with them. So please do get in touch. So we will continue discussing these events. Next week, there will be a conference. I just wanted to make an announcement, Regenerating Asia 2050, Asia Pacific Futures Network. And then we will have a large event initiated by UNESCO, High Level Futures Literacy Summit. So I'm hoping to meet you in one or both of these events next week and in early December. I'm also the editor of the Foresight Journal, and I want to take this opportunity to welcome our two colleagues as regional editors, Dr. Jonathan Keloff and Dr. Yin Huang. Our regional editors for Jonathan is for North America and Ying is for China. So I'm looking forward to working with them, and please do consider Foresight as an outlet for publishing your research. So thank you very much for your patience, and I'll be happy to answer any questions you may have.
Thank you. Thanks very much, Ozcan. That was fascinating. And I'm looking for any questions in the chat. And there is one raised in Zoom, I think by Lin Zhu. Would you like to ask your question?
Yes, thank you, Professor Saritas. Thank you for your brilliant presentation. So I'm very interested in your sustainable thematic clusters you mentioned. Could you say some words about how did you get them? I mean, what's the method? How did you get the the sustainable maybe topic clusters?
Let me try to see which one actually you mentioned. So topic clusters for sustainability.
Yes.
You said?
Yes.
Well, we have the topic clusters. Let me just share my screen again, just to make sure that I'm looking at the right picture. So is it this one that you're talking about?
Yes, thank you. That is my question.
Yes. Right. So this is again looking at the wide variety of references through semantic analysis.
Mm-hmm.
So we used some as data input. We used a large number of data coming from different sources. So sometimes we actually use the sources in a kind of mixed way and bring together some reports from, for example, international organizations, and then again combine them with research articles and sometimes also with patents, and try to look at the kind of semantic relationships between different concepts. So these sustainable thematic clusters were built by looking at the semantic relationships between these concepts. We use, I mean, like my colleagues can tell much more details about this, but 200 vector analysis. So try to kind of map each of the documents and then look at the proximity of keywords, not only co-occurrence. So we also look at the proximity, for example, whether they are used in the same sentence, next to each other, in the same paragraph, and try to kind of position them and then identify kind of some kind of a metric based on them, and then build those pictures according to that. I can send some of our publications which explain in detail how we make use of this visualizations.
Okay.
Thank you.
Thank you. Thank you, Arthur.
Oscar, let me ask you this question. So you did highlight the increasing use of big data and machine learning and other methods. Two questions related to that. One, does that change how you think policymakers and other decision makers actually receive and take action on foresight? And secondly, what are your thoughts about bias in these methods? You know, there's the beloved discussion about bias in machine learning and AI, and foresight could be subject to that, maybe consensus thinking as opposed to divergence thinking. But I'm just wondering your thoughts on those two aspects.
Yeah, these are very good questions, Phil. Thanks a lot. These tools are actually very helpful for us. First of all, when we start, for example, a foresight exercise, we don't, by using these tools and analysis and evidence, we don't start anymore with a blank sheet. So we can actually put something on the table already for discussion. And then, as I said, we try to bring kind of together the expert-based processes and database processes. And then it connects to your next question, where we don't consider this like as absolute truths, but actually use them kind of to set an agenda. So they are for discussion, and we don't claim that they are complete or represent kind of the full reality, but at least they give us a good framework to begin with. So when we try to integrate this in the foresight exercise in our processes, we saw that this saved us a lot of time. And sometimes we did it vice versa. We started working with experts and brought this analysis in, and then experts saw that there were some points that they didn't consider. So it really helped them to enrich their agenda and then to give some multiple outlooks or some new items. So of course, nobody can read like hundreds of thousands of documents. So that's why it creates a very valuable input to our studies. But again, we never claim that these are absolute truth. We show the visualizations. So you see, these are the issues, these are the relationships between them. Sometimes they are contested, and we also respect to that. But we try to use kind of as decision support tools. Just, you know, new evidence base for our foresight exercises.
So thank you. I think our time is up for this keynote session. So let me thank Professor Louis and Dr. Saritas for fantastic presentations.